1.5 and 1.6 we're going to review together, but 1.5 is on inequalities and 1.6 is on absolute, which I'll abbreviate as ABS throughout, value, equalities, and equations. If you want to just take out a sheet of paper and jot down some examples, these are again just review notes from Algebra 1. So if we think about absolute value as the formal definition being the distance of a number from 0 on a number line. And if we think about the concept of distance, distance is always positive. So when we're thinking about absolute value, just remember that it's always positive because we represent distance, that measurement, with a positive number. So as a quick example, when we first saw this and we saw absolute value of -3, we would say, well, how far is -3 from 0? The distance away would be 3. So when we get used to absolute values, we just think of it as it's always positive because it represents the distance. Now within an absolute value equation, we have the absolute value of x is equal to 3. And we're trying to, remember, when we're solving an equation, we're trying to isolate x. So therefore, what values of x has a distance of 3 away from 0? And then that yields two answers, x equals 3 or x equals -3. Both are 3 units away from 0. And so anytime we're looking at any absolute value equation, we have that the absolute value of an expression is equal to, let's say, a number. So we want to know in this case, if I add 5 to a number, what number then would be 8 units away from 0? So in order to solve these types of absolute value equations, we do the same thing as we did with example number 1, where we set up the absolute value being equal to a positive unit distance away of 8, and the expression that we take is inside the absolute value equation. So essentially we've dropped the absolute, so let me highlight that. So the x plus 5, we're going to take that and we set it equal to +8 as well as -8. And then if we solve for both of those, 3 and -13, both if you add 5 to it, are 8 units away from 0. So we have x equals 3 or x equals -13 is a possible solution. So if the equations have more things on the side of the absolute value expression, so such as 4x, absolute value of 4x plus 3 minus 2 equals 5, has the extra -2 on one side, what we would then do is move and isolate the absolute value expression further by writing this as absolute value of 4x plus 3 equals 7. And then at that point, we would now take the 4x plus 3 and set that equal to a +7 as well as a -7 and continue to solve the rest of the way. Why don't you hit pause, solve the equation, and fill in what your solutions are for this example number 3. Okay, for example number 4, we get, well, what would happen if we have a problem where the solution might not make sense? So let's say we had 4w plus 3 within the absolute value bars, plus 7 is equal to 5. So like the above example, we're going to work with isolating the absolute value expression. So that means we're going to subtract 7 on both sides. Absolute value of 4w plus 3 within absolute value. So we make sure you don't drop the absolute value bars until you've isolated the absolute value expression, and then you're ready to set up two separate equations for solving. So 4w plus 3 equals -2. Well, let's stop and pause for a moment and think about why would this problem not make sense? Okay, so we noticed that in our previous problems, absolute value from the definition represents the distance of a number from 0 on a number line. And that distance, and if you can watch my highlighting, the distance on the right always was a number that was positive. And that makes sense. It's for that first example, it's 3 units away. For the second example, it's 8 units away. For the third example, it's 5 units away. Well, this problem, we're saying it's -2 units away. Well, that's never possible. We can never represent distance with a negative number. So there will be no solutions that work out to -2. So we kind of have to catch this and be aware of the fact that the absolute value can never be negative, so there is no solution. So we'll say absolute value can never be negative. Okay, and it's important as we go through and solve that we're also able to make sure the answers and solutions that we have make sense. So for the above problems, you'll notice that you only had just the absolute value expression set equal to a number. It's always safe for us to go back, plug the values that we had for our solutions back in and make sure that it makes sense. So on example 5, we'll see that these absolute value expressions might be set equal to not only a constant value on the right like we've had in the above problems, but to an expression with variables in it. So absolute value of x plus 5 is equal to 3x minus 7. So as opposed to the problems above, where the right-hand side, what I highlighted was just all numbers, we have absolute value expressions that have it's set equal to an expression on the right-hand side that also has variables in it. So it doesn't really change much. We still take what we have in our absolute value x plus 5, and we set up two separate equations. So that expression, the absolute value expression is isolated on the left, so we're good to go. And we set it equal to a positive expression on the right, as well as take the expression that's highlighted and set it equal to a negative version of the right-hand side. So again, representing positive and negative, and then going forward and solving. So if I solve this one, subtract x, I get 5 equals 2x minus 7, add 7 on both sides, 12 equals 2x, so x therefore is 6. So from this first equation, I get x equals 6. On this other side, I'm going to go ahead and distribute the negative, add the 3x on both sides, 4x, subtract the 5 on both sides, 2, x equals 1/2. Now we're going to take the two values that we have, x equals 6 and x equals 1/2, and check our solutions. So if I plug 6 back into the original equation, so check x equals 6, and check x equals 1/2. So if you can input your answers, is 6 a solution, is 1/2 a solution, and or are both solutions. So if you plug it back into the equation and you get that the equation makes sense, it's true, then it is a solution. So if you want, go ahead and hit pause and then see what answer you get. So you should have gotten, if you plug 6 in, that 11 equals 11. Well, that makes sense. So that means that x equals 6 is a solution to the problem. Now if I plug 1/2 in, I get 1/2 plus 5, or absolute value of 5.5 is equal to 3/2 minus 7. And If I do 3 halves minus 7, I get negative 5.5, which is not equal to the absolute value of 5.5, which is positive 5.5. So this doesn't make any sense. And so the more complicated absolute value equations where you have x's on both sides, you want to double check, and it's just probably safe to check all your solutions and make sure that it's true before we say that it is an answer. So once again, x equals 6 is a solution, x equals 1/2 is not a solution. So we will hit pause here and then move on to inequality.